Hello, welcome to this tutoring session. Today I'm going to talk about partial derivatives. I know this is a big problem for most college students in like engineering, business, economy. Um, at some point, if you're taking calculus 3 or doing some, you know, course that requires partial derivatives, you'll come across this. So let's go ahead and get to the point. Now, if you you know, are asked to find the partial derivative of this function with respect to any of these variable here, x and y, um, don't think it's, impossible or, too hard. The thing is, you just have to know which one to consider as a constant, but also and then which one should be considered as a variable. So, and I know I said like a constant, but that constant, you don't really derive it. So you just basically leave it alone. Because I know in the actual derivatives, if there is a constant by itself without any variable as a coefficient, as a multiplier, it will basically go to zero. But in this case, whatever you consider as a constant doesn't go. If it's a variable, I mean, if it's a letter, like if you're doing df dx here, that y you consider it as a constant, but you don't derive it to go to like zero. So let's do an example. Let's say you asked to find a partial derivative of f with respect to x, right? With respect to x, that means any other thing is constant and only x is the variable. So you have 9y squared x squared. So that 3 multiplies the 3 coefficients, these two, and then y you just leave it alone because you deriving this function with respect to x, and then plus 2y. Like I said, this 2y is kind of like we consider it as a constant, but we don't derive it, so just leave it alone like that. And this is it. This your result. df dx is this. Now in df dy, also same scenario, leave x alone, derive y. So that would be 6x cubed y plus 2, and that's it, and but sometimes, or most of the time I should say, they give you a function like that and also tell you that these are function of other variables, like x and y are also functions. So they will probably give you something like this: x equal to 2t cubed and y equals to let's say 5t, right? And then they'll ask you to find the derivative of f with respect to t. Instead of them asking you straight to do these, they'll say find df dt, right? They'll ask you to find that. Well, when they ask you to find this, there's you have to use the chain rule sort of formula, but I basically kind of memorize that in my head, and I'll call in my method of studying how to do this, I call this first function second function, its variable, right? So if I have to find df dt, I know I have to do the partial derivative. Well, that's basically the rule I'm explaining here. So partial derivative of f of the big function, right? Big function with respect to the first function. So, dx, that times the derivative of the first function. But also be careful, is the first function dependent on two variables, three variables, one variable? If it's more than one variable, you have to do partial times partial derivative, right? Times partial derivative of that function, right? But here it's only one variable t. So you'll understand why I say that in just a second. So if it's one, so I do dt, like actual derivative of that dt with dx. This would be dx here with respect to t. That plus partial derivative of big function with respect to the second function times the derivative. Does it have two variables or one variable? Okay, so I have to do the actual derivative. I call it actual derivative, which I don't think it's an actual term, but that's how I can remember to do it. If it's one variable, I say actual derivative. That means the normal derivative, we always do in like calculus 1 or so. So that means dy dt, right? So so that's it there. And if you can get these and multiply them, you'll be good to go. Okay, and then once you have that, you can go ahead and do it. Or you can also do the derivative tree. All right, so you put the big function, which is f. How many variables that function depend on? Two variables, x and y. So I put x, put y. Now, does x depend on how two variables, one variable? Well, in our case, it depends on one variable. So I just put one variable, which is t. Y also depend on one variable, which is t. So here from f to x, well, f has two variables. That means here I have to do partial derivative. So df partial x as well. Same thing here, partial f dy. And I go down as well. X has how many variables? One variable. That means actual derivative, right? So regular derivative, which is dx dt. Same thing here, dy dt. Now once I have this, then I can go ahead and write my formula. Actual df dt equals to partial df dx times actual dx dt plus this side, and that's what you have there. Now what if your x and y depended on some other function like s, like s, for example? That means here you have, say, erase this. That means here you have two variables, S and S, right? And like I said, if you have two variables, that means go ahead and do partial, right? So you have, instead of actual, you have partial x, partial t, right? Because they're asking you to get df dt. So partial x, partial t. If they ask you to do df ds, then you do partial x, s. So say, and you do the same thing here, partial dy, partial dt, right? And then instead of actual dx and dt here and dy here, you put partial as well, and then solve it like that. So this is how you go about to solve any partial derivative equation. All right, so let's go ahead and solve our problem here. So we want to find this. We already calculated partial of f with respect to x and y. So let's go ahead and calculate the actual derivative of x and y, right? So dx dt equals to what? This will, don't forget to erase these. These are not part of it. Now those were examples. So we'll have what? 6t squared, and then dy dt will be just 5, right? So, and then go ahead and plug in those we just got. So we'll have a partial df dx is 9y squared x squared plus 2y, that times actual dx dt, which is 6t squared. So we'll have 6t squared plus partial df dy is 6x cubed y plus 2, that times 5, and go ahead and solve for that. And you can also replace, now that this is basically your result there, right? You can go ahead and factor out, develop all these, and also replace y and x and y by the actual values here, since they're asking you to get the derivative with respect to t. So we'll go ahead and do that. Let's go ahead and do that. It will be 9 y is 5t, and that squared, x is 2t cubed, all that squared, that's also 2y is 5t. So you just replace those values in it, and and do the same thing there. 6x is 2t cubed, and cubed here, times y, which is 5t plus 2, and 5. And if you solve this, you'll get a smaller number, I think, smaller function, and that will be your derivative. So if you like this video, please subscribe to my channel to get more videos like this. And if you have any questions, don't forget to post it in the comments. Please like this video to help me make more videos like this.